Cutting through ice to understand the behavior of glaciers. Imagine cutting through a stick of butter. You end up with two smaller sticks of butter. Now try cutting through a block of ice. Under the right conditions, surprisingly, you don't get two separate pieces. Instead, the ice magically fuses back together, remaining as a single block. This fascinating phenomenon is called regelation. Simply put, regelation happens when pressure causes ice to melt into a thin layer of water, which flows and then refreezes once the pressure is removed. You might have seen this demonstrated with a wire being pulled through ice by weights. The pressure from the wire melts the ice beneath it, and as the wire moves on and the pressure eases, the water refreezes above the wire. This effectively allows the wire to cut through the ice without breaking it apart. Dr. Colin Meyer of Dartmouth's Thayer School of Engineering and his colleagues aim to better understand this process. They investigate regelation under subtemperate conditions, meaning much colder temperatures than typical room temperature experiments. This is important because glaciers, vast rivers of ice that shape our planet's landscape and climate, exist in these colder environments and behave differently. Studying glaciers directly is tough, so Dr. Meyer's team analyzes careful laboratory setups, mimicking glacier conditions by pulling wires through ice blocks at various temperatures. They also analyze experiments with different wire materials, thicknesses, and conductivities. At room temperature, the melting caused by pressure is significant, so regelation happens quickly. But as the temperature drops, only an ultra-thin liquid film, just a few thousandths of a millimeter thick, forms and the melting slows dramatically. Using data collected from many such experiments, Dr. Meyer and his collaborators developed a general model to describe regelation across temperatures. They discovered that the process follows a power law. Small decreases in temperature cause huge reductions in the melted water's thickness and, consequently, in the speed of regelation. In simple terms, even a slight drop in temperature can drastically slow down how ice melts and refreezes under pressure. Understanding regelation isn't just a neat physics trick. It has real-world importance. Glaciers affect sea level rise and influence how much sunlight Earth reflects into space, which are both key factors in climate change. By improving our knowledge of how ice moves and melts, this research helps create better climate models, giving us more accurate predictions for the future of our planet. In summary, Dr. Meyer's work illuminates the hidden physics of ice, bridging laboratory experiments to the vast, icy landscapes of our world, and helping us better understand climate change through the behavior of glaciers.